I'm going to present the last keynote of this ICT 2022. So it's for me, it's my pleasure to present all of you to Kelly Blincoe. Kelly is a senior lecturer of software engineering at the University of Auckland, New Zealand, although I think she's not there right now. I don't know. She's in this human aspects of software engineering lab, HASL, in the Department of Electrical Computer and Software Engineering. Her research is mainly on the human and social aspects of software engineering. She takes a socio-technical perspective, considering the interaction between the social and the technical aspects of software engineering. You can find more information of Kelly on the conference webpage. There are a link to visit her page. So, according to her background, Kelly will present us today her talk entitled Creating Better Software by Centering Diversity, Equity, and Inclusion, which is directly related to the human dimension of software sustainability, which I think is of main importance. So thanks, Kelly, for accepting our invitation wherever you are. I don't know exactly, and I give you the words. Thank you very much.
Thank you very much. And thanks to all of the organizers for inviting me today. I am not in Auckland at the moment. I'm in the United States. I'm on research and study leave or sabbatical. And so I am visiting at the US at the moment. So I'm not too far from all of you. I wish I could be there in person with you today, but I hope you're all, those of you who are in person, enjoying your time together. So I'll just share my screen. And I assume that you can see that. Okay, so in this talk, I'm going to discuss how software can exclude and discriminate. And I'm going to describe some key considerations for more inclusive and therefore more sustainable software. But I thought that first I would situate my talk in sustainable software engineering more broadly. So prior research has advocated sustainability must consider 5 dimensions. So those are the technical, economical, individual, environmental, and social. And this image is highlighting technical and economical because historically they've been given the most research focus. Of course, I know that this community, this research community, is looking at sustainability more holistically. And so, of course, you're considering all of the dimensions. In this talk, though, I'm going to focus on just one aspect of sustainability. So specifically social sustainability and specifically one of its subfactors. So Dubach et al. Defined a sustainability framework, and one of the subfactors of social sustainability that they defined was inclusiveness and diversity. So I'm hoping that this talk will convince you that to create sustainable software, we need to give more focus to inclusiveness and diversity in all of our research. Okay, so what does it mean to focus on inclusiveness and diversity? Well, before I give my thoughts on inclusion, I'd like to talk a little bit about exclusion. So what does it mean to be excluded? Exclusion for software can happen when we don't consider all of the possible users of our software products and how they will use the software products. Many of you have probably seen this image. What we see here is a walking path design. So it has harsh 90-degree angles with the concrete path. But then you see a person walking in a worn path in the grass. So they're taking a shortcut. They're choosing not to go with the design that the city planners had made. This image is often used to represent the difference in how design works and how users use products. The city designers clearly design paths that are not in line with how people are using them. Now, in this case, people can simply walk somewhere else, right? They don't need to adhere to the design. But in many other cases, particularly in software, if the design is not accommodating users, the software is simply unusable for them. Let's look at an example from the broader field of software engineering. So here you see a picture of a crash test dummy. And I'm showing this because crash test dummies were initially designed around the average size of an adult male. And today, still, because of this design, women are 17% more likely to be killed in a car accident than a man of the same age. And they're 73% more likely to be seriously injured in a car accident because of the design of these crash test dummies. Now, this is a very extreme example of exclusion, how design can literally be killing people because they haven't been thinking about all of the people that will be driving and passengers in vehicles. And for an example specific to software, let's consider YouTube. So I don't know if you know, but when YouTube was first released, approximately 10% of videos were being uploaded upside down. And the reason for this comes down to not considering all users' needs in the software design. So think about how you hold your phone when you're taking a video. No matter which hand the phone is in, you're going to turn your hand in towards the other hand if you're taking a video in horizontal mode. So left-handed users are holding their phone in an opposite direction than right-handed users. And the software simply did not accommodate for this. So the primarily or maybe all right-handed users on the software team and testing team didn't consider the needs of left-handed users. So their videos were being uploaded upside down. Another example, inequity can be even more problematic with the dramatic rise of artificial intelligence. Consider the case of Amazon's recruitment tool. It was designed to shortlist CVs. So it's helping to reduce the effort of hiring teams. It was trained on the historical CVs of candidates who'd been hired at Amazon. It inadvertently was excluding nearly all women applicants. And this is not because it was trained to consider gender, but because it found certain features in the CVs of this historically successful candidates at Amazon. Things like having been on the men's football team or having gone to an all-boys high school. This is because the workforce at Amazon was primarily men. And so the AI started giving preference to CVs with these types of items, and it inadvertently was excluding women. You might have also seen Twitter's image cropping algorithm in the news last year. Twitter was automatically cropping images, and many users were complaining that the algorithm was biased. The images here show an example. On the left, you see 4 different vertical configurations of 2 different people. So you see a white man in a business suit and a black man in a business suit. And if you uploaded each of these 4 vertical images to Twitter, no matter what order the people were in, or no matter how many times each person appeared in the picture, Twitter cropped the image to show the white man's face, as can be seen on the right hand of this slide. So the AI had built-in racial bias. And while YouTube has fixed its problem for left-handed users, Amazon and Twitter fixed their algorithms simply by removing them. So Twitter now just enables users to crop their own pictures. It no longer tries to automatically crop pictures. And Amazon stopped using this secret recruiting tool that was excluding women. But if we want sustainable software that will endure, we need to design these systems with inclusion in mind, not just abandon them when bias is detected. So we need to make sure that as software continues to be used across all aspects of society, that it's not further embedding inequities. We need software processes that are human-centric. They need to put the needs of all people at the forefront, not just the needs of the majority. But the good news is that often addressing issues of accessibility can make the product more useful for everyone. So think of curb cuts as an example. So this is the slight dip in the sidewalk or the footpath that was originally designed to help wheelchair users navigate sidewalks. But while their primary purpose was to provide easier access for wheelchair users, they made cities more accessible for everyone. So parents pushing strollers, bike riders, skateboarders, people who are using walking aids or pulling their luggage or delivering packages, they can all navigate cities more easily now because of curb cuts, even though these needs were not necessarily in the forefront when they designed curb cuts. Everybody is finding that they're more useful and you know, it has made the city more accessible. Another example related to software are closed captions of videos. So historically, closed captions were created to help people with hearing impairments consume the audio component of videos. However, especially with the advent of social media, we see captions benefiting nearly everyone. People scroll through their social media feed and watch videos without their volume. They may not be wearing headphones, but they're in a location where the volume could be disruptive. And with captions, a video can be understood, even if you're not listening to the audio. A recent study actually found that 80% of users are more likely to watch a video if captions are available. So this goes back again, while the captions were not originally designed for everyone, they have made it easier to consume videos for everybody. So if we find that it is, if you focus on the needs of some underserved people for technology, it can make software better for everyone. Well, how do we go about knowing what those needs are? So requirements elicitation is the process of collecting or gathering software requirements. And traditional techniques involved interviews, so talking to users about their needs, focus groups, so getting a group of users together to talk about needs, also questionnaires, so putting out a questionnaire where you can get a larger subset of people to tell you about their needs, or observations, observing what users are doing now so that you can understand what their needs are, or document analysis, so seeing what their processes are and things through their documents. But some of these techniques may miss segments of society. So they need concerted effort to include diverse perspectives, especially since the number of users that can be involved in these types of processes is limited due to time constraints. So you can't interview every user of your software product. But these techniques can also have a lot of inherent bias, particularly selective perception. So the requirement engineer's own perceptions can cloud how they understand requirements. There can also be miscommunications and lack of shared understanding that can lead to misunderstood or missed requirements. User-centered design is an approach that brings the users into the full process. So having more users involved can lead to catching missed or misunderstood requirements early. So this process basically has the users really involved and embedded in the entire design process. But again, this also, while it can help solve these miscommunications and help ensure that diverse perspectives are being considered, it does require consideration to ensure that the diverse perspectives are being involved. So it's not just a matter of inviting a random subset of users, but it really is having to take the effort to make sure that you're having diverse perspectives. And only a limited number of users can be involved in this type of design process, again, due to time and resource constraints. A study by Humancentric et al., which examined requirements engineering for people with cognitive disabilities, concluded that inclusive requirements engineering in a software project requires intensive communication between all participating stakeholders. Collecting requirements from a diverse set of users may require different elicitation techniques to be used, since not everyone would be comfortable or able to participate using the same methods. And it can be time-consuming and expensive. Therefore, for it to be done well, there needs to be a lot of motivation and drive to focus on inclusion. And we don't see this on all software projects, where time to market may be considered more important. Another approach that can help focus on software inclusion is Gendermag. So Gendermag is basically a cognitive walkthrough process where you consider the usability of a software product after it has been designed, using different personas. So the personas for Gendermag have been created to consider 5 different cognitive facets that I show here. So motivations, your information processing style, computer self-efficacy, attitudes towards risk, and style of learning new technologies. Now, prior research has shown gendered differences in these facets. For example, women are more likely to have comprehensive information processing styles. So this means that they might want all of the required information up front before they start a task. On the other hand, men are more likely to use a selective information style. So this is where they get started based on a subset of information, and then they are happy to potentially backtrack to obtain other information as they need it. In terms of style of learning, women are more likely to prefer to learn by process, for example, tutorials or how-to guides, while men are more likely to learn through experimentation. Of course, this is not to say that all women or all men have the same cognitive styles. I certainly don't feel like I align with the women styles that I've just described, and the research here is also limited to binary gender. However, Gendermag is based on the premise that if a software product caters to only one style for these cognitive facets, it will be more difficult for people with the other style to use the software. And since there are gender differences, so more women might align with one particular style, then this could imply that there's gender biases in the software, because if your software doesn't cater to the style that does have more women associated with that style, then you're not designing your software for women particularly. So using these personas can help uncover inclusion issues as well. However, the use of personas can be controversial in HCI research. They can certainly help to uncover issues, but they can also help to perpetuate existing stereotypes. So like I said, it's all women kind of mentality. And they require empathy. It's not easy to put yourself in someone else's shoes and accurately estimate the issues that they may encounter with a software product. So inclusivity problems can still be missed. Another area of research that can be promising for eliciting requirements from a more diverse set of people is crowd-based requirements engineering. So there's a huge amount of online user feedback in App Store reviews or on Twitter or on online user forums. And there's so much promise in that leveraging, all of this available information online could help software teams better understand user needs and identify software product improvements. And this means that you'd be able to hear a wider range of user voices by leveraging this crowd-based information to identify software requirements. Because you're hearing from so many more people, you're no longer limited to the time that it takes to interview someone, but you have all of this information available. And research has found that there is requirements relevant information in this online user feedback. So Pagano and Malige found that approximately 1/3 of App Store reviews contain requirement relevant information, including bug reports, feature requests, and user experiences. And other recent studies have found similar requirements relevant feedback on Twitter and on user forums. So there's a lot of requirements relevant information online in these online sources, but there's so much of it. So a substantial amount of research has been happening recently to try to develop techniques that can automatically extract or filter requirements from this data. So techniques have been automatically classifying this feedback into predefined categories like bug reports or feature requests, or clustering together similar feedback so that you can find all of the feedback on a particular issue, for example. These techniques can help extract requirements from large amounts of data online. However, the question is this actually going to bring more diverse user perspectives, so that if that's the goal? In some of my recent research, we directly surveyed over 1,000 software users about their feedback habits. And responses indicate that there are statistically significant differences in who gives feedback in each of these online channels with respect to traditional demographics. So the charts here show differences across binary gender and age in who gives feedback on different feedback channels. You can see that men give more feedback than women, but interestingly, the type of feedback given also varied across gender. Men were more likely to request changes and report issues. They reported being more motivated to influence improvements, whereas women reported being less aware that they could influence improvement just by writing an App Store review, for example. And some women also reported that they found App Stores confusing to use. It was difficult to leave reviews. Also from our sample, our largest groups of respondents came from Germany and China. And we also saw differences in motivations across these two groups, with respondents from Germany being more likely to be motivated to influence improvement, whereas Chinese respondents indicated that they just wanted to give feedback so that they could recommend or discourage others from using apps. So online feedback might not be as representative as we hope that it is. And how we prioritize this feedback from online sources also matters. So prior work has developed techniques to help prioritize what to change in a software product based on online user feedback. The techniques have considered features like sentiment and ratings, frequency of the feedback, retweets, likes, or number of followers of the person giving the feedback. And this risks amplifying and prioritizing voices of the majority. So are the most important issues those that are affecting the most people, or the most popular people if we're considering retweets and number of followers? Or are they the ones that have the most serious consequences? So if your software product is not accessible to people who use screen readers, for example, there might be less people who are complaining about this issue, but should it be low priority simply because there's less people that are voicing this concern? And another aspect that matters for software development teams being able to be aware of the needs of all of society is the representativeness of the software industry itself. So various studies have shown that diversity on software teams can bring benefits. For example, improved productivity, increased innovation, and more usable software. So when we bring diverse perspectives into a software team, they're able to cater to more diverse perspectives of software users as well. So we can create better software simply by having more people, more diverse perspectives involved in the software development creation process. But we also know that the software industry lacks diversity. Software is created mostly by cis, heterosexual, white, and Asian men. Here, the first chart shows New Zealand's diversity stats for the tech industry. I know we often see the US-centric data, so I thought I'd share New Zealand data here. But we see that the New Zealand industry is also dominated by white and Asian people. And the bottom chart shows women's representation in big tech companies. And this is based on their annual diversity reports. It shows that less than 25% of women, less than 25% of tech jobs are held by women. So you see that there might be more people in the tech workforce, but the different bars, the blue bars representing people that actually have tech jobs in these big tech companies. So women are less than 25% in the actual jobs that are involved in creating software. And we know that more diverse teams are going to bring more diverse perspectives and create more inclusive software, but it's much harder for teams without diversity to consider the needs of all of society. Okay, so why am I showing you a picture of a blobfish? The blobfish has been said to be the world's ugliest fish. But how does that relate to software and sustainable software? Well, this is what a blobfish actually looks like in its natural environment. It looks like a normal fish. It needs the pressure of the deep water to keep its body together in its normal position. So when it's in a different environment, a wrong environment, it doesn't thrive. And we can't blame the blobfish for this. We need to blame the environment. So that brings me to the software industry. Is the environment in the software industry one where everyone can feel included and welcome? There's a lot of evidence, both empirical and anecdotal, that it is not. Studies have found negative sentiment and emotion in software engineering discussions, and these have also been associated with negative outcomes, so reduced productivity or reduced quality. However, negative sentiment can be expressed for many reasons, like healthy disagreements, and it's not in itself indicative of unhealthy communication in software teams. But recent studies in open source software have found evidence of gender bias, discrimination, and toxicity. And there's also reports that a similar discriminatory, toxic culture exists in software companies like Apple and Facebook. A recent study at Google investigated pushback during software code review, which they defined as negative interpersonal interactions with peers during your code review. And they found negative experiences, including personal attacks and harsh communications. Now, they found that these were relatively rare at Google, but they did find that when they did happen, that they had negative repercussions for those who were involved. In recent years, many projects have begun to adopt codes of conduct. So codes of conduct can define standards for how to engage in a community, and it can signal an inclusive environment that respects all contributions. It can outline the procedures for addressing problems if they do occur. Now, this is not just open source software, but companies have begun to adopt codes of conduct. Conferences and events also tend to have codes of conduct these days. Here I'm showing you a screenshot of the contributor covenant, and this is a kind of template code of conduct that has been designed so that open source software projects can simply adopt this code of conduct with some minimal changes to make it easier for open source software projects to have a code of conduct. However, there are some members of the open source community who openly oppose codes of conduct. They've even started a no code of conduct movement. The premise of this no code of conduct movement is that all members of open source software community are adults and therefore they know how to treat each other. Now we know that people from different cultures have different norms and different expectations, so this is very unlikely to be true that everybody will know how to treat everybody else. And so having codes of conduct can just help set the ground rules and the baseline for expectations in a community. Now, despite the fact that many open source projects have adopted codes of conduct in recent years, there's still evidence of toxicity. So this is a recent study. This image comes from a recent study by Miller et al. That was just presented at ICSE, the International Conference of Software Engineering, last month. And they examined toxicity in open source software projects through a qualitative analysis. And they defined toxicity as rude, disrespectful, or unreasonable language that is likely to make someone leave a discussion. And what they found is they found insulting comments, arrogant comments, entitled comments, unprofessional comments, and trolling. But what's really shocking about this is they didn't find it just from new accounts or people that were kind of joining a software project just to be disruptive. They found that people who were very experienced developers and core members of the project team were exhibiting this type of behavior. And these toxic comments were not just directed at code, so not just critiquing code that somebody created, but they were also directed at the people themselves on the team. So insulting or trolling or being arrogant towards people themselves. One particular activity where toxicity can be problematic is software code review. So this is where software contributions are examined by other members of the team. And code review is a common practice on software teams, and it's long been used to improve software quality. And it can bring a lot of benefits, including improved software quality and knowledge sharing. But there's also reports that code review can create toxic or unsupportive environments. And this tweet is illustrative of a problematic view by some in the software industry, that code review can be honest or nice, but not both at the same time. And there are software developers who state that real software engineers, whatever that means, should be able to take harsh criticism. So some of my own recent work has looked at perceptions of feedback in code review, particularly looking at how developers perceive destructive criticism. So destructive criticism is negative feedback that is both non-specific and inconsiderate. And studies of destructive criticism originated in the field of applied psychology. And so in other domains, they've found that destructive criticism can provoke negative reactions in the recipient. For example, reduced productivity or motivation. And they also found that destructive criticism can be higher for women for some types of tasks. So we wanted to find out if similar negative reactions occurred when destructive criticism was received during software code review. We did this through a questionnaire. So we provided some hypothetical scenarios to developers who were completing our questionnaire. So we gave them, imagine that you've just submitted this code. We gave them a code snippet example, and this is the feedback that you get on that code. And the feedback was randomized. So each participant received 2 of these scenarios, and about half of them received destructive criticism in the first scenario, and the other half received destructive criticism in the second scenario. And the ones that weren't receiving destructive criticism were receiving constructive criticism. And we asked the participants various questions on how they perceived that feedback. and how they would react to the feedback. So I'll just share a few of my results here. These charts are showing the differences between constructive criticism and destructive criticism and the perceptions that the participants reported. So we asked participants if they thought the feedback that they received would improve their code, if the feedback was valid, and if the feedback was appropriate. You can see clearly differences between the constructive criticism at the top and the destructive criticism at the bottom. So the green indicates agreement. So at the top, you see most participants are agreeing that constructive criticism would help improve their code, it was valid, and it was appropriate. Whereas at the bottom, for destructive criticism, we see much more disagreement, the gold. So particularly, participants thought that the destructive criticism was inappropriate and that it wouldn't help improve their code, although they still did, for the most part, believe that the criticism was valid. So even though you're giving me valid critique of this code, because it's so inappropriate, I'm not going to improve my code. So I can't even take this feedback on board to improve my code because of the inappropriateness of the destructive criticism. We also asked participants how motivated they would be to consider working on the task with the developer or on the project. And again, you see very clear differences between constructive criticism and destructive criticism. So the constructive criticism at the top shows strong agreement. Developers are motivated to continue working after receiving constructive criticism. On the bottom, you see strong disagreement. So this is particularly with the developer that gave the destructive criticism. Developers would not be motivated to continue working, but also on the task and on the project itself, developers would be less motivated to continue working if they received destructive criticism in our hypothetical scenarios. But we also uncovered some conflicting opinions. So we also asked some general questions in this survey about their general opinions of destructive criticism. So not just based on the scenarios that we gave in the beginning. So here you see 3 different questions. The first 2 bars are quite generic. We asked participants if they thought destructive criticism was harmful and if they thought it would cause a negative reaction in the recipient. And overwhelmingly, the participants agreed with these statements. So yes, destructive criticism is bad. It can be harmful. It can cause a negative reaction. But when we asked a slightly more nuanced question, the question was, when receiving code review comments, I don't mind getting inconsiderate feedback as long as the feedback helps to improve the code quality. And here we started to see differences. So while still most people disagreed with the statement, they didn't want to get inconsiderate feedback, there are 30% of our respondents that agreed with this statement. They are happy to be abused by members of their team as long as it will improve the quality of the code. And we also saw similar sentiment coming out in our open-ended responses. So we asked also developers to provide some general open text kind of feedback on how they saw destructive criticism. And we saw 2 key trends emerge. So the first was developers who said, actually, I don't mind if feedback is harsh or inconsiderate. I just need easy to parse feedback so that I know what to change in the code. So, and the other kind of segment of the comments were saying feedback always needs to be considerate. I won't learn and I won't want to continue working if I receive inconsiderate feedback. So we really saw 2 different kind of viewpoints coming out when we asked more generally about destructive criticism. And we also examined demographic differences. So here I'm just showing the statistically significant demographic differences. We saw women reported to perceive destructive criticism as less appropriate, and they were also less motivated to continue working on a project with the developer and on a task after receiving destructive criticism in our hypothetical scenarios. So this goes back to the graphs that I showed in the previous slides, and we compared the responses across gender. We had really only statistically significant differences across women and men because the number of non-binary respondents was very small, but we saw women were statistically significantly less motivated to continue working and perceived destructive criticism as less appropriate compared to men. We also saw less experienced developers were less likely to call out destructive criticism. So we asked participants, after receiving the feedback in these hypothetical scenarios, if they would respond to the person that gave this feedback, what would they write? And we evaluated the differences in what people wrote. And we saw more experienced developers, not always, but sometimes would respond to the feedback and call it out and say that it was inappropriate and it was rude or inconsiderate. Whereas we only saw one of our less experienced developers do this. They hardly ever called it out. In fact, they were more likely to apologize for the problems in their code when they were being given destructive and inconsiderate feedback in their review. Interestingly, across all of the different things that we looked at, we didn't see any differences across open source software contributors and industry software developers in our participants, both in the amount of destructive criticism that they reported to receive or to give, and in their perceptions of destructive criticism. We couldn't find any statistically significant differences across open source software and industry, which is interesting because often people will say that this is really just a problem in open source software, which is open to everybody, and industry doesn't necessarily have these kind of toxic problems. But in our results, of course, we can't conclude that there is a problem just because of a small sample and a lack of evidence of differences, but we did not see differences between open source software and industry. So if there's a culture of needing to be able to accept harsh criticism to be a real software engineer, when I look at this, I think, who are we driving away? And so this destructive criticism that we're giving in software code review and the culture around being able to accept harsh criticism potentially could be causing retention issues in the software industry, and particularly for women, since we see that there are differences here across gender. And this study, my study, was not the only one to have looked at differences across software practices and software tools regarding different demographics. A previous study found that debugging strategies, that there are differences in gender for debugging, how people debug their code. This study found that women use different debugging strategies, and even when they use the same debugging strategies, they use them slightly differently. And they concluded that actually debugging tools are designed with the strategies that are more likely to be employed by men in software teams. Of course, this is not a surprise, right? If men are the dominant members of the teams, the tools are likely to be designed for them and by them. Another study found code reading comprehension strategies also differed across gender, with women employing different strategies to read code and to understand code that they're reading. And again, this comes down to, are the tools being designed to cater to everyone here if people are using different strategies? Another study found that GitHub has inbuilt gender biases. So this goes back to the Gendermag method that I discussed earlier. This study used the Gendermag method, and they looked at the different cognitive facets of the Gendermag personas, and they considered how GitHub catered to all of the different cognitive facets. And they found that GitHub did lean towards the certain styles of the cognitive facets that are more common in men and less common in women. So they found that GitHub would be harder to use by women. And so this can bring cognitive, overhead, additional work in order to do your job, because the tools are not necessarily designed for you. Now, the three studies that I've just described are all related to gender. A recent systematic literature review by Rodriguez Perez et al. Found that gender is the most studied diversity dimension in software engineering. And almost 70% of the papers examine gender when they're looking at diversity and inclusion issues in software engineering. We don't see similar studies that have looked at tools and practices in software engineering across other diversity dimensions or intersectionality. And this is very much needed so that we can understand where our tools and practices are failing us and creating exclusion in the software industry. However, we have seen some research that has looked across other diversity dimensions, and this is particularly in pull request acceptance rates. So we've seen studies have found that there are pull request acceptance rates differences across gender, race, and nationality. This does not go to say that there's some way that things are being done differently, but it possibly hints at discrimination in how these pull requests are being considered for acceptance. All right, and another funny picture for me. So this picture is a picture of 5 monkeys, and it relates to a study, a research study that is said to have studied 5 monkeys in a room with a ladder and bananas at the top. So the story goes that a research team was studying these 5 monkeys, and anytime one of the monkeys tried to climb to the top of the ladder to get the bananas, we all know that monkeys like bananas, the research team would spray the monkeys with cold water, and not just the monkey that tried to climb to the top, but all of the monkeys. And the monkeys didn't like getting sprayed by this cold water. So over time, the monkeys tried to stop each other from climbing up to the ladder to get the bananas. So anytime that a monkey tried to climb up the ladder, the other monkeys would pull it down and beat it up. So eventually the monkeys stopped trying to get the bananas because they didn't want to get beat up and they didn't want to get sprayed by water. So then the research team replaced one of the monkeys. So now there's a new monkey and it doesn't know any of this history. So instantly it tries to climb the ladder. The 4 monkeys, knowing that they might get sprayed by water or get beat up, pull the monkey down and beat it up and try to stop it from getting the bananas. Over time, this monkey learns that it should stop trying to get the bananas, even though it's never been sprayed by water. Eventually, the research team replaces all the monkeys. So the room is filled with 5 monkeys that have never been sprayed by water, but they continue to, anytime a new monkey is joining the room, they continue to pull it down off the ladder and beat it up to stop it from getting the bananas. So how does this relate to what I've been talking about? Well, I think it is just an interesting story to kind of reflect on thinking about how we do things and why we're doing things that we're doing. So these monkeys, they don't know why anymore they're beating each other up to stop them from getting the bananas. Right? Things have changed. Maybe they can go eat those bananas. How can we encourage them to go and do things differently and eat the bananas? And similarly, how can we reimagine software engineering tools and practices to center diversity, equity, and inclusion? So I challenge all of you to consider how we can do this. And I think it comes sometimes to our own research. So much of our research, my own included, assumes that developers' actions are the ground truth. We evaluate our new methods and our new tools based on what developers do now. But how can we design for the software engineering community that we want and not the one that we have now if we're always basing our results on what's currently being done? Similarly, who are we including in our studies when we make recommendations for software tools and software practices? Now, this, of course, is a challenge. It's really hard to get participants in our studies if we're doing human studies. And considering diversity across multiple aspects is even more challenging. I recently did a study, the one that I was talking to you about code review, and I wanted to study the full gender spectrum, but we only ended up with 3 non-binary participants and the rest identified as women or men. And it was really hard to make conclusions when you only have 3 non-binary participants. So we thought, how can we go out and get more? And we looked at platforms like Prolific that might enable us to find more participants. But when we looked, if somebody on this Prolific platform willing to do surveys was a software developer and identified as non-binary, and there was only 6 people available on the platform. So even if we invited all 6, it's very unlikely that we would have dramatically increased our numbers. So there are limitations. It's not easy to get diverse samples for every study that we do, but at least we need to acknowledge this and report. We can't make claims that the recommendations that we have, the guidelines that we have in our research are suitable for everybody in software engineering if we're only talking to a subset of software engineering practitioners. And if software engineering is already lacking in diversity, we need to think about, the future software engineering practitioners that we want. So just because right now we have more men in software engineering, as an example, we shouldn't say that it's okay to not have women in our studies because mostly men are on software teams. We want women to join software engineering, and we can't make conclusions purely based on the men that are already on the teams now. So we need more research on how we can embed inclusion in software design, software education, and software research. So how can we embed inclusive design into software engineering? How can we educate the future software engineers to design for inclusion? How can we ensure that our own research is not further embedding inequities? Are we actively considering the needs of marginalized groups? And how can we design methods and tools for diverse and inclusive software engineering community? So these are all things that, we don't have easy answers, but I'd like to challenge you to kind of consider and keep in the forefront so that we can center diversity, equity, and inclusion in all of our research. And just to close, I'd like to thank all of my collaborators on the different studies that I discussed today, but as importantly, also my team, the Human Aspects of Software Engineering lab at the University of Auckland, who are pictured here. So all of these people, including my collaborators and students in this lab, have impacted the way that I think and influenced this talk, even if they did not directly participate in the studies that were involved. And I'd like to open it up for discussion and questions. And once again, I'd like to thank the organizers and all participants for attending, and hopefully for fruitful discussions to come.
Thank you very much, Kelly.